Now, if we go with what we talked about, about trig identities, and if we said that it's just a relationship between trig functions, and we saw the reciprocal identities and the quotient identities. So look at that second quotient identity, cosine over sine is equal to cotangent, right? That just shows the relationship between sine, cosine, and cotangent. Now, is there a way that I can write that in a different way? So can I say, for example, that what's cosine of theta is equal to then? How can I rewrite that in terms of cosine of theta? It's equal to what? Cotangent of theta times sine of theta, right? So just because it was given to you in the book as cosine over sine is equal to cotangent, it doesn't mean that you can't, that you're not allowed to write it in a different way. Does that make sense? Yeah. Okay. Now, so that's the reciprocal identities and the quotient identities. Let's talk about Pythagorean identities, right? Okay, so the Pythagorean theorem is what? It basically says x squared plus y squared is equal to z squared. Okay, so now, if I have an angle drawn like this, and that lands in the second quadrant, and if I look at the reference angle, right, the reference angle is here, that angle intercepts the axis at that point. So how do I get to that point? I have to go an x amount along the horizontal axis. I have to go up a y amount along the vertical axis. Okay, so to get to that point, I have to go a horizontal distance of x and a vertical distance of y. Now, if I were to find that radius, right, then it would be, if this is x and this is y, then that would be x squared plus y squared is equal to 1, right? X squared plus y squared is equal to 1 squared. Does everybody agree with that? Is that right? So that's what I have written here. X squared plus y squared is equal to 1. Okay? Now, another way to write x squared plus y squared equals 1 is x squared is cosine theta squared. Y squared is sine of theta squared, right? And so if I have sine of theta squared, I can also write that as sine squared theta. Those two mean the same thing. Okay, those two are two ways of writing the same exact thing. So I can write sine of theta squared or sine squared theta plus cosine squared theta is equal to 1. And now look, this is called the Pythagorean identity. All right? Now, the Pythagorean identity has friends, okay? So if I take sine squared theta plus cosine squared theta equals 1, okay? And now, if, just for fun, I decide to divide everything by cosine squared theta, check out what happens. Okay, now, here I have sine over cosine. What's sine over cosine? Tangent. Now, sine squared over cosine squared is tangent squared. So if it was sine cubed over cosine cubed, it would be tangent cubed. So this will be tangent squared theta plus what's cosine squared over cosine squared? 1 is equal to what's 1 over cosine? Secant. And 1 over cosine squared is secant squared theta. And look at that. That's that second identity. Okay? So now, if I take my Pythagorean identity, sine squared theta plus cosine squared theta equals 1. Now, everybody knows that. Everybody knows that sine squared theta plus cosine squared theta is equal to 1. That's just what it is. And if I were to take that, and if, just for fun, I divided by sine squared theta this time. Right? What do I get for the first part? Sine over sine is 1 plus cosine over sine is cotangent, so this is cotangent squared theta is equal to cosecant squared theta, and lo and behold, that's that third one. So, moral of the story, we all know this. Everybody knows this. You need to memorize this, okay? The other two, you derive, okay? The other two, you derive. All right, now, take a look at the unit circle. Here it is, okay? Did we memorize the unit circle? No. Okay, now, let's take a look at an angle. Here's an angle. Okay? It happens to be pi over 6. Now, so that's theta, yes? Now, if I wanted to look at negative pi over 6, would that be here? So can I say that's negative theta? Okay, now let's take a look at the coordinates for theta and negative theta. What do you notice? What patterns? What's the same and what's different? Huh? So the y coordinate is negative. How about the x coordinate? It's the same. Does that make sense? If you're here, if I have theta and a negative theta, the x value is going to be the same. The y value is going to be positive and negative, right? So if the y value is sine of theta and the x value is cosine of theta, then look, I can say that cosine of the negative angle is the same as cosine of the positive angle, right? So if you have theta and negative theta, the cosine will be the same. If you have theta and negative theta, what about the sine? Will they be the same? They will be the negative of each other, right? So sine of negative theta is the negative sine of positive theta. Okay? And that leaves tangent. What's tangent? It's y over x, right? So now, look at positive theta. If I were to do y over x, what would the SIGN sign be? Positive. If I do y over x here, what would the SIGN sign be in the bottom? Negative. So then, tangent of theta, okay? If you have a positive angle versus a negative angle, tangent of theta differs in sign. So tangent of negative theta is the same as tangent of theta. So then you're like, okay, we totally got lucky. Okay, well, let's pick a different two. Let's pick a reference angle of pi over 4. And let's pick a reference angle of pi over 4 this way. So this is my positive angle. This is my negative angle. Okay? Does it hold true? Are the x values the same here? Yeah, the x values are the same. Are the y values the same? No, they have a negative difference, so the sign has to be a negative difference. Okay? And then tangent is the same. Yeah. Uh-huh. Uh-huh. Mm-hmm. Mm-hmm. So suppose it was positive 400 and negative 400. Is that what you're saying? Uh-huh. Mm-hmm. Oh. Okay, so the way it would be is this is positive 135 degrees, right? This is negative 135 degrees. Do you see that? Yeah, it's the same amount. Okay? Okay? Yeah. Okay. So now let's do complement of an angle. So take a look at this. Okay. Now let's take an angle. Let's take 30 degrees. Okay? All right. 30 degrees is here. Yes? How much is the sine of 30 degrees? 1/2. Now, what's the complement of 30 degrees? So what's 90 minus 30? 60. Right? What trig value for 60 degrees will give you 1/2? Cosine. Do you see it? I see it too. Okay? This is an identity. So look, if you have 30 degrees, and let's say the sine of 30 degrees is 1/2, right? So if you do 90 minus that, okay, the cosine of that angle would be 1/2. So let's do another one. Yeah. So suppose cosine of let's do sine again. So suppose sine of 40 degrees is equal to, I don't know, some value x. Okay? Now, what's the complement of 40? 50. The cosine of 50 would have the same value. Okay? Yeah. That's exactly why. For the 45, it's the same. So sine of 45 is equal to √2/2. What's the complement of it? Yep. Okay? Yeah, exactly. So now, let's say sine of 20 is equal to some value, a. Okay? What's the complement of 20? 70. So cosine of 70 equals a. All right? So the way we write it is sine of 20 is equal to the cosine of what? 70. And these add up to 90. All right? So here is where the takes effect, right? So remember how there is sine and cosine, but sine and cosecant are the reciprocals? Well, sine and cosine, secant and cosecant, tangent and cotangent, this is it. Okay? Sine and cosine are related, that the complement of an angle is the cosine. So if you have cosine, pi over 2 minus theta is sine. If you have tangent, pi over 2 minus theta is cotangent. Okay? It's the same as 90. So if you have sine of 90 minus theta, that's cosine of theta. Okay, so these are called cofunction identities. All right? These are the cofunction identities. Okay, these are all the identities in one place for you guys. Okay, so here we go. It says find the exact value of sine if cosine is this. All right, so for these, you have to identify two things: what you have, what you're given. What you're given and what you need. So you're given a cosine, you need a sine. And now you have to ask yourself, is there an identity that relates sine and cosine? So here, is there an identity that relates sine and cosine? And I don't want to throw any other identities in the mix. So is this a good one to pick? Is sine over cosine equal tangent a good one to pick? No, because you don't want to put in a tangent. So what's an identity that doesn't have anything else? This one. Okay? Sine squared theta plus cosine squared theta equals 1. Now, what is this business about? This is telling you that your angle falls between 90 and 180. Which quadrant is that in? That's in quadrant 2. So that means, okay, like that, you're going to use that to fix the SIGN sign, okay? All right, so let's find sine of theta. All right, sine squared theta plus, now this is cosine theta squared. Am I given cosine theta? Yeah. What is it? Negative 1/2. So it's negative 1/2 squared is equal to 1. Okay? So now sine squared theta is equal to 1 over 4. I'm sorry, plus 1 over 4 is equal to 1. So what's sine squared theta? 3/4. Okay? And now what do? Take the square root of both sides. So now sine of theta is what? Plus or minus root 3 over 2. Now, why? There we go. When you do this mathematically, you have to show me that you get 2 answers. Out of these, we're only going to pick the one that falls into our quadrant. We're in quadrant 2, and that quadrant sign is positive. So quadrant 2 implies sine of theta is equal to positive root 3 over 2. Okay? No, just, you know, like, you'll get this, plus or minus root 3 over 2, and then the answer column just put the answer, root 3. Okay, find the exact value of secant if sine is blah, blah, blah. Okay, how can we relate sine to secant? Let's fix the quadrant first. What quadrant is this in? Third. So how can we relate sine to secant? It might be 2 steps. There we go. We're going to use sine squared plus cosine squared equals 1. Find the cosine, then find the secant. Oh my God, how fun. Let's do this. Sine squared theta plus cosine squared theta is equal to 1. Now, negative 2 over 7 squared plus cosine squared theta is equal to 1. 4 over 49 plus cosine squared theta is equal to 1. Now, I got to do 1 minus 4 over 49. So this is 49 over 49 minus 4 over 49. So take the square root, and cosine of theta is equal to plus or minus 3 root 5 over 7. But am I going to take the plus or the minus? He says minus. I think I'll go with minus. Cosine of theta is negative 3 root 5 over 7. So what's secant of theta then? Right? Yeah, so it's basically it's 49 over 45, right? So it's 7 over 3 root 5. Huh? So we say that secant of theta is 1 over cosine of theta. Seven root 5 over 15. Okay? Oh, and it's negative. Negative. Yeah, you have to take the negative. Okay. Now, next, we're going to talk about simplifying expressions. Okay? Simplifying is when you basically, you do some like algebraic applications to something. At the end of the day, you know your expression is simplified when it's broken down into like the most basic trig functions. All right. So what we're gonna do here is rewrite in terms of sine of theta. If it says in terms of sine of theta, that means you can only have sine of theta. Okay? Right. No, not sine of theta. Like in your expression, there's no equal sign here, but in your expression, you're only going to have sine of theta. No cosine, no tangent, no nothing. Okay. When in doubt. Okay? Yeah, that too. When in doubt, here's what you do. Switch everything and write everything in terms of sine and cosine. Okay? So that's a good strategy. The best strategy is write everything in terms of sine and cosine. All right, so let's do that. What's cotangent in terms of sine and cosine?
Cosine squared theta over.
Right. Minus sine squared theta over cosine squared theta. Now, can I do a common denominator with this? This is why I learned about common denominators. So, sine squared theta times cosine squared theta is in the denominator. And now, what are we going to have here?
Two cosine squared theta minus 2 sine squared theta.
2 cosine squared theta? Okay, so let's do this one now. Simplify so that it can be written in terms of one trigonometric function, right? Okay, so now, sine of theta times cosecant minus sine. Okay, what's cosecant? Now, none of these are squared, so I can't use the Pythagorean identities because all the Pythagorean identities have squared. Right. So this is sine of theta 1 over sine of theta minus sine of theta. Now, can I distribute that sine of theta? So I get sine of theta over sine of theta minus sine squared theta. Check out how cool this is. Oh my gosh. 1 minus sine squared theta. And what is 1 minus sine squared theta? Cosine squared theta. Okay? I know, this is amazing. This is good stuff. Okay. Yeah. Okay, yeah. Sure. The Greeks. Okay. Okay. I have secant of theta times 1 over tangent of theta. Can I write it that way? Okay. Now, what's 1 minus cosine squared theta? 1 minus cosine squared? Sine squared theta. Yeah. Now, everything in terms of sine and cosine. So secant is 1 over cosine theta. Okay. Okay, so what's tangent? Sine over cosine. What's 1 over tangent? Cosine over sine. Times sine squared theta. Now, cosine, cosine go away. Sine goes away with one sine, and I'm left with sine theta. All right? So it says to write in terms of one trig function. There we go. It's one trig function. If you have sine and cosine, no good. Okay? All right, here we go. Let's try to do the same here. So tangent squared is sine squared theta over cosine squared theta, right? That's all I did, is this one. Now, what's cosecant squared theta? 1 over sine squared theta minus 1 over, what's secant squared? 1 over equals. Now, what can I get rid of here? The sine square and the sine squared. So what I have here is 1 over cosine squared theta minus 1 over 1 over cosine squared theta. Can I cancel out the cosines? No, because there is a minus 1. So you know what I have to do? Common denominator. So here I have cosine squared theta. No, it's minus 1. Well, you would multiply this and that. No. You would have to multiply. No, it's a little different. Because you're dividing by 1 over cosine squared, you would have to multiply by 1 over cosine. It's a little bit more complicated, so you can't do that. Let's do it this way. This will be 1 minus cosine squared theta. Is that right? Okay. Now, what's 1 minus cosine squared theta? Sine squared theta over cosine squared theta over 1 over cosine squared theta. So now look, this is, remember the outers over the inners? Sine squared theta cosine squared theta over cosine squared theta. And then you cancel out the cosine squared, and what are you left with? Okay, I have to admit it's a little satisfying. All right, there is like that sense of like gratification in the end. Okay, so there we go. Who would have thought it would simplify to that? But it does simplify to that. So you have to stick it through. Strategies. A major strategy is try to write everything in terms of sine and cosine. And at each step, ask yourself, okay, what identity goes here? What identity goes here? What identity can I use here? 99% of the time, you're going to be using the Pythagorean identities and the reciprocal or the quotient identities. These, okay, show up. They show up more like rarely, but when they do, man, it's quite a show when they do show up. Okay, all right.